So the first place where we need to start, we need to somehow describe our player. So for this, I created this chess player class, and this is very simple class for now. It holds just the ID and the name value. Because our application becomes more and more complex, we can add something called namespaces just to keep this code better organized. Here is also one important thing. It's we implement this interface because we would like to export our user to some kind of file, database, or wherever to be able to load those details in the future. Yeah, so we have this implementation. This is the required method, and that's what we will return as a data of our object to be serialized. So let's add the namespaces. Here you can see that this is undefined, and that's because the same here, because now we need to tell our application to use this namespace, and now everything is correct. So let's go back to our player for a second. This is very weak solution. I would recommend avoid using this one. So I prepared a helper class for us that will generate a UID for this user. And that's how this generator looks like. And here you can see it doesn't belong to chess, right? Like we had here the word chess, because this is kind of a utility class, and we may want to use this UID in any other place of our application, engine, or any other project. That's why it is in a different namespace. So how we can use it? So instead of this one, we need to provide path to our generator, and this is static, and in this simple way we have UID as a ID of our user, which is a modern and pretty cool solution. And because this is a zero stack project, which means we have to include this class, because our script has no clue about from where should take this information. You can use Composer or any other autoloader, but that's out of scope of this project, so we will do this manually, like this. Once we have our class player class created, so we can also include it here. And if we would like to use it later in this file, we need to use this class. And as we talked at the beginning of this video, we have engine, we have a player, so now we need to have something that will join those two pieces together. And I created a class called chess local, because this is something that will allow us to play chess games locally. So this class is very simple. We have an array of players. Let's start from the top. It belongs to chess, so that's why it is in a chess namespace. It's called chess local. This is the file where we are going to store all information about players. As a players list, here we have optional current player. It might not be set, right? So that's why we have to have this as an optional value. We can load players from our file, and we will return our own object. So if the file exists, it might not, but if so, then we take this content, because we are going to store this as a JSON. We do this decoding, and we go through players. Based on these players, we create new objects, and we add them to this array. And we also can find a default player if there is any, and if there is, we set the current player to this player. Remember that this will be an object, so this is just a reference. We can also create a new player. Yeah, that makes sense. As a return, we will get a chess player. We provide only name because ID can be generated for us automatically. And then we store this this player in our array. If it's our first player, it will be also our current player. Save players. We have our list of players. We take our current player, we take its ID and store this as a default. Here we store in this file that we provided on the very top, and we store this as a JSON data. List player is just a kind of helper, yeah, because players, it is a protected value, so we do not allow anyone to modify this value, kind of. The same is with the current player. We return null or reference to this player. We can also change our player, and we may want to look for some players. So that's how this very simple players management look like. So of course we need to add this here. We create a game somewhere here, so let's move it to the top. We create an instance of our chess local game, and we try to load players when the application starts. So now we can go to our menu and add some positions. So let's start from the simplest part, which is our help. That's how our commands will look like. If someone will type new underscore player, colon, and then the name, we'll create a new player. Local underscore players will list all available players. So now we need to add these cases here. Here we are going to add new players, and we know that we can add new players only using this local, this instance of the chess local. So we don't want to create many instances of this class because it doesn't make sense. So we are going to pass this object here. So how this content is going to look like? Well, creating a new player is very simple. We have our action, yeah, with this pattern, and if the player name will not be provided, it may happen. Then we will use this as a default name for the player. If in other case, we will use what was provided. Here we have our instance of our game. We call a new player method that requires us to pass new player. So we create a player user, we provide a name, we do not provide ID because we don't have to, and once we add this player, we also save this. And as I talked previously, here we have message, so we will display information to end user. Actually, not we prepare a message to be displayed later that the new player with this name was created. And as you can imagine, local players will be also very simple. What we need to do is to take a list of available players. If the players list is empty, we'll display that there are no local players yet. In other case, we start displaying them from on the screen. Here we go through every player. We take player's ID, name, and if it's a current player, we will display this asterisk to emphasize that this is a currently set player. And this is a very simple index. If it's over the screen height, we will not display anything else to avoid any weird scenarios. The screen size is 26, so I guess for the sake of this example, it's good enough. We don't need more than 26 players. And that's how the welcome screen looks like. You can see add two new positions, new player and local players. So let's see what we have here. No local players, makes sense. Help, yes, new player, and new player dwarf was created. Local players, you can see UID, login, and the asterisk to emphasize that I am currently currently selected user. What is missing? Let's go to our board. We still display P1 and P2 here, right? So it's time to change it. And we are here where we display our P1, P2 players. So let's assume that our currently selected player is always a player 1. So how we can do this? So it's a local, say current player. We know that it might be null, it might not be set, so it might be null save. And let's take the player's name. In case it's null, we want to display P1 as it was before. So let's save it and see how it works. In the meantime, I removed my list of players. We are in our application. Let's see our local players, no local players. Let's see board, it's P1, help, new player, create, local players, created, board, and there's my name, A1 to A3, go to move, and for the player number 2 we have P2 as it was before. There's one more thing that I would like to add right now. We don't need it right now, but because it belongs to players, I think it's a good place, a good moment to do so. I'm talking about the player. For now, we have name and ID, but because this is called a network game, we need to somehow protect our data. Yeah, we will be exchanging our data with our with other players. It's called local because we execute this locally, but it's a network game, so the data can be modified by our opponents, and we would like to avoid this. That's why we need also some kind of encryption. The best way to encrypt data in our case is to use asymmetric encryption, and for this we need to have a private and public key. I created a class, it's called encryption. It's also in utils, the same as generators, this UID generator is. And we have generate keys, very simple method. It returns us a key with the certain algorithm, and as a return we have private and public key. We have also two functions to do encryption and decryption. We need to add this to our constructor like this. Why we need this? Because we serialize and unserialize users. So we create these private keys when we create a new user, but we also want to load them once we load users from our local file. And similar to ID, if the private key is empty, we would like to use our generator, assign those values. If those values were provided, we will not override them, but we will store them as a class property. And the very last thing, we need to add this to our definition for serialization. Otherwise, those values will be missing during serialization. Also, the same as we did for an ID and name, we would like to add some getters for those values. So now our class is complete. We have pretty solid ID identifier. We have private keys. We'll use them later. So this class is done. Our game is fixed, I guess. Everything seems to be fine. So that's it for this episode. In the next episode, we will add similar management, but this time for games. So we will be able to create new games, load games, and also exchange the games with the other players. So thanks for watching and see you next time.